Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on ring theory, lecture number 12, in which I will prove some theorems and solve some problems on integral domain. Now we prove a theorem. Theorem is the characteristic of an integral domain is either 0 or a prime number. Now we prove this. Let D be an integral domain. Therefore, D is a non-trivial ring. Since characteristic of a trivial ring is 1, therefore characteristic of D is not equal to 1, as D is a non-trivial ring. Let characteristic of D is M, therefore M is an integer and M greater than 1. We have to prove that M is a prime number or 0 integer. Let M is not equal to 0, and if possible, M is a composite number. Therefore, M equal to P multiply Q. P is greater than 1, less than M, and Q is greater than 1, less than M, PQ belong to Z. Let this is number 1, this is number 2. Since characteristic of integral domain equal to M, we have already considered this, implies that I be the unity equal to 0, I be the unity of D. Unity means unity element. Implies that in place of M we write P multiply Q, I equal to 0. Implies that Pi multiply Qi equal to 0. Since D is an integral domain, therefore it contains no divisor of 0. Here we have seen that Pi multiply Qi equal to 0. It is only possible when Pi equal to 0 or Qi equal to 0. No divisor of 0 means. Therefore, from 3, Pi equal to 0 or Qi equal to 0. This is number 4. This is number 5. From 4, Pi equal to 0 means characteristic of D less than equal to P. From 5, Qi equal to 0 means characteristic of D less than equal to Q. This is number 6. This is number 7. From 6, characteristic of D is M. M less than equal to P. From 7, M less than equal to Q. This is 8, this is 9. Since from 2, M is greater than P, M is greater than Q. This is 10. Therefore, 8 and 9 contradict with 10. Therefore, our assumption in 1 that M is a composite number is wrong. Therefore, M is a prime number. Therefore, characteristic of D equal to a prime number. This is number 11. If we do not get any M belongs to Z such that Mi equal to 0, then characteristic of D will be 0, means we are not getting any M. This is number 12. From 11 and 12, we get characteristic of an integral domain is either 0 or a prime number. Proved. Now we prove the next theorem. Next theorem is, if the characteristic of an integral domain D be a non-zero number P, then order of every non-zero element in group D with binary operation addition is P. Now we prove this. Let D with binary operation addition and multiplication is an integral domain, and also let characteristic of this integral domain D equal to P. We know that the characteristic of an integral domain is either 0 or a prime number. But here given that non-zero number P, that is P not equal to 0. Therefore, P is a prime number, characteristic of D is P, and P is a prime number. Let X is an element of D such that X is non-zero element. X is not equal to 0. Now, Px equal to x plus x plus dot 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 plus x, P times addition. This equal to x multiply unity element plus x multiply unity element plus x multiply unity element plus dot 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 plus x multiply unity element. By distributive law, x multiply unity plus unity plus 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 unity, P times addition. This equal to x multiply Pi This is number 1. Since characteristic of D equal to P implies that Pi equal to 0. This is number 2. From 1 and 2, we get Px equal to x multiply 0, that is 0. Therefore, order of x with respect to binary composition addition divides P, that is order of x divides P. This is number 3. Since P is a prime number, so P is divisible by 1 or P itself. That is, therefore, order of x equal to 1 or P. This is number 4. Since only 0 element of D has order 1 with respect to binary composition addition. Since if we add 0 one time, then we get 0. Here binary composition is addition. But since x not equal to 0 here, therefore order of x equal to here P. Since x is an arbitrary non-zero element of D, therefore order of any non-zero element of D is P. Proved. Now we solve a problem. Problem is, prove that the ring Zn with binary composition, addition and multiplication is an integral domain if and only if n is prime. Now we prove this. Let Zn with binary composition, addition and multiplication is an integral domain. Then properties of integral domain is, number 1, it is a non-trivial commutative ring. Number 2, having unity element. Number 3, having no divisor of 0. Again, since it is non-trivial, therefore n not equal to 1. Now we have to prove that n is a prime number. If possible, let n is a composite number. Therefore, n equal to p multiply q. P, q belong to Z. P greater than 1 less than n. Q greater than 1 less than n. Let this is number 1. Since PQ equal to n implies that P bar Q bar equal to n bar, and n bar means 0 bar equal to 0 bar implies that P bar multiply Q bar equal to 0 bar. This is number 2. Since Zn with binary composition, addition and multiplication is an integral domain, so it does not contain divisor of 0. Since P bar not equal to 0, Q bar not equal to 0, therefore from 2 we get that Zn contains divisor of 0, because in 2 we see that product of two non-zero element is 0 element. That means contains a divisor of 0, which is against the definition of an integral domain Zn. Therefore, our assumption is wrong. Our assumption that n is a composite number is wrong. Therefore, n is a prime number. Proved. Conversely, let n is a prime number and m not equal to 0, m bar belongs to Zn. Therefore, GCD of m and n equal to 1. Since n is a prime number, so GCD of a prime number and any number equal to 1 implies that mx plus ny equal to 1 implies that minus ny equal to mx minus 1 implies that n divides mx minus 1 implies that when mx is divided by n, remainder is 1. That means mx is congruent to 1 modulo n. Let this is number 3. Let x is congruent to r modulo n. Means when x is divided by n, remainder is r. Implies that mx is congruent to mr modulo n. Here we have right to multiply m only when the GCD of m and n is 1. Since GCD of m and n equal to 1. This is number 4. Therefore, from 4 and 3, we get here in 4 mx congruent to mr modulo n, here mx congruent to 1 modulo n. That means mr is congruent to 1 modulo n. This means that when mr is divided by n, leaves remainder 1. That means m bar multiply r bar equal to 1 bar. Class. This is number 5. This means m bar is a unit in Zn. Unit means it has multiplicative inverse r bar. M bar multiply r bar equal to unity of Zn. Implies that m bar is not a divisor of 0. Therefore, the ring Zn with binary composition, addition and multiplication contains no divisor of 0. As Zn contains unity element and commutative also with respect to multiplication, and here we get contains no divisor of 0. Therefore, Zn with binary composition, addition and multiplication is an integral domain. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.